Hello everyone, welcome to the video. My name is Abhijit Nadgowda. I'm a Microsoft certified trainer and a cloud solutions architect working at Cloud Technologies. I bring 19 plus years of experience in the IT industry working across infrastructure, cloud technologies, and enterprise solutions. In this video series, we will be covering important concepts that will help you prepare for AZ-305 designing Microsoft Azure infrastructure certification. So today's topic is Azure networking solutions. We will be discussing key networking components such as virtual networks, subnets, network security groups, endpoints, and connectivity options like VPN gateway and ExpressRoute. This will help us connect on-premise infrastructure with Azure. So let's get started with Azure networking fundamentals. So let's start with understanding bit of basics about Azure Virtual Networks, the fundamentals, before we look into architecting solutions. So this will be kind of a refresher. So when we say Azure Virtual Networks, these virtual networks are software defined in nature. We call them as SD networks also. Now these networks are managed at layer 3. So basically it has all the physical security that is required and the routing mechanism and the switching mechanism in the back end. Everything is taken care of by Microsoft. And these virtual networks support RFC 1918 IP address policies that includes private IP address range, that is your 10.0.0.0/8. Then you have 172.168.0.0/12 and 192.168.0.0/16. So it is recommended you use these private IP address ranges only for creating your private network, which is on Azure. Of course, these network also support other IP address ranges, but they will still remain as a private network. For example, if you go and create a network with this IP address range, it will still support creating, but it is not recommended. This is used in very special or rare case scenarios. So we will primarily focus only on these three IP address ranges. Now, these virtual networks are regional in nature. That means one entire virtual network can span across all the three zones. That is, if I have, let's say, three virtual machines here in this example, and all of these are deployed in, let's say, East US region, and I have to enable private communication between these VMs. So we can add all these virtual machines in one single virtual network, which by default spans across all the zones. So it doesn't matter if this virtual machine is in zone 1, zone 2, or zone 3. So by default, these virtual networks span across all the regions. We cannot go ahead and create a virtual network which is limited to function only within one zone. So it's by default across an entire region. So let's say we have another requirement of enabling communication with other virtual network in different regions. So you have a few more. Let's say I have one more virtual network in another region. Do they by default communicate with each other? Answer is no. So these are isolated by default. So let's say you have two virtual network. So these virtual machines can communicate only within this virtual network, or at the most they can communicate with internet. So all the routing required for these communications are automatically taken care of by Microsoft. And when there is a requirement of enabling communication between two different virtual network, whether they are in the same region or different region, or whether they are in the same subscription or different subscriptions or different tenant, we have to enable something called as peering. So with the help of peering, we can remove this isolation and help them communicate with each other, where all this entire traffic, the private communication traffic, remains on Azure Backbone Network, which is a global physically isolated network that connects all the data centers in Azure. We call it as Azure Backbone Network. And if you want to see the robustness of Azure Backbone Network, let me just show you how it looks like. Here we go. So this gives you an idea about the robustness of the infrastructure, what we are dealing with in Azure. So let's go to explore the globe, and here we go. You see here all these denote a presence of a region. So these are the region where there is a presence of one or more Microsoft data centers, Azure data centers. And all these lines that you see, these are all the submarine cables that connects all the data centers across the globe. So you can call this one of the uh, biggest private network service in the world. So when you enable peering between two virtual network, it doesn't matter whether the virtual networks are in the same region. They could be in any of these regions. Like I have one virtual network in, let's say, East US, and I have another virtual network, let's say, in southern part of India, somewhere here, which is in the totally opposite direction of the world. So we can still enable this communication and keep it private using private IP address based communication. So uh, this traffic do not traverse over the internet. It uses the robust infrastructure of Azure, and uh, and also, of course, not to mention about the bandwidth and speed that comes along with it. So that is how robust this infrastructure is. So we have another feature here that is for virtual network. When we create virtual network, we are by default we are forced to create subnets. Now subnets are used for segmenting your network, where resources that require different port filtering requirement can be organized in a more efficient way. So whenever we are creating any virtual network, let's say I am creating a virtual network with an IP address range. So for this training purposes, I'll be using 10 series IP address range. So let's say I have 10.0.0.0/16. This is the IP address range I'll be considering for training. Of course, this is a very big network. It's not practical to use such a big network in actual scenarios, but for training, we will use it. So this IP address range has around 65,536 unique IP addresses. Now, if you compare such a big network with a physical network, this will end up creating a very huge broadcast domain, which will hamper your performance and the responsiveness. So it is recommended that whenever you are creating with big network or any virtual network for that matter, you have to segment these, and that is what we call as subnets. So here we go. I will go ahead and create multiple subnets here. I'll call it as web tier, which is, let's say I'll take a chunk out of this IP address range. So I'll say 10.0.0.0/24. Then I'll use this as business tier. So let's say 10.0.1.0/24. And then I have our DB tier, let's say this is 10.0.2.0/24. So by uh, this kind of configuration helps you to deploy Azure resources or virtual machines which require same port filtering requirement like my web servers if I want to host. which needs to be open for communicating through ports 80 and 443. I will add these virtual machines in the subnet. Then you have business logic processing servers. So let's say they use port 5000 for communication. So I'll use this subnet. And then I have my DB servers. Let's say they use 1433. So I will deploy them in the subnet. What is the benefit? Benefit is if I put them in different subnets, configuring these ports to remain open and closing the rest of the ports which are of no use can be done in one shot using services like NSG and ASG, that is application security group and network security group. So segmenting is there. Segmenting is very, very important. Plus we have other features like built-in DNS service. Azure provided DNS service, we can go for this. This is infrastructure provided DNS service. You can also go for a custom DNS solution using PaaS, using Azure DNS Zone or DNS Private Zone. And also you can go for IaaS approach where you end up creating your own virtual machines and on the OS level you configure DNS service, so which can be taken care at the entire VNet level. Other features include DDoS protection mechanism, which is built in. You have both free and paid service, which is your standard plan for DDoS protection. So this feature just needs to be enabled. You don't have to configure anything in this. Everything is automatically taken care of by Microsoft. So these are some of the basic features of these virtual network. And of course, not to mention, we have already discussed that, these virtual machines within the VNet, they communicate freely with each other using any port and protocol. We don't have to define any routes for this. And also, these virtual machines can easily communicate with internet, so that they are able to communicate with the internet. It's not like they will be exposed to the internet. They have only private IP address range. So these are some of the features of virtual network. Now let's look into the other aspects from the architect side. So before we even get into architecting side, so let's look into uh, the common security practice, what we call is defense in depth. Here we go. So when it comes to recommending a network architecture solution, we have to follow a strategy, what we call as defense in depth, where your entire infrastructure is secured using different layers. So as you see here, uh, the physical security of the data center is very important. That is taken care of by Microsoft by managing the data centers on behalf of you. And when it comes to identity and access, we have some services like PIM, that is privileged identity management, and conditional access that will take care of identity and access. Perimeter layer security, we have DDoS protection and Azure Firewall Service. Network layer security, we have services like network security group, application security groups. Compute level security is taken care by configuring host security. Application layer security will take care like container security. And when it comes to data, we have Defender for cloud storage and Azure information protection. So the strategy talks about having various services on every level so that attack against one layer will protect against other layers, so that will be isolated. So this is one of the strategies one needs to follow when we are planning for network. So what are the things that we have to take care when we are recommending a solution for network? The first thing is the naming convention. So when we are planning for network, the naming convention plays a very important role. So the name should give out information about what is the purpose of the network, and region details we should include in there. We also take care of defining what is the workload going there. So those details we have to think of before we select a name for a network. And the reason being is once you assign a name to a network, you cannot change them. That is the properties of the virtual network. So not just virtual network, any Azure resource for that matter, if you consider, after deployment, there is very little room for making any kind of changes later. So this becomes very important. Also, it comes very handy when it comes to managing the network because you have selected the naming correctly. That gives out way more information about the network. Then consider in the region where you are deploying your virtual network, where you have data residency concerns, or you will select region based on various scenarios. Like one is the data residency, second is proximity to the end users, then probably the latency considerations you will have to take care of. Then whether your virtual networks are spread across a single subscription or multiple subscriptions. Usually the general practice is that all the connectivity related services are deployed on a particular subscription, which will be very easy to manage. And that way you have to select the appropriate subscription for deploying these VNets. Segmenting your virtual network using subnets, and also if required take care of the connectivity side using peering, whether it is VNet to VNet or whether it is on-prem to Azure in a hybrid scenario. Security, permissions, who should have access to it, what level of access should be defined using RBAC roles, and of course the policies which will allow you to govern these network. So all these need to be planned well in advance before you even begin with thinking about a solution for a given scenario. So let's now talk about Azure Network Connectivity Services, what we have. So here we have different topologies. Now you see, you have hub and spoke, and this is one of the most recommended topology by Azure. Why it is recommended, let's go on and understand. So if you see, I'm planning to host, let's say, multiple applications on Azure in a particular region. So I have this VNet, which is hosting a particular application, let's say app A. I have app B, and we have another app C. Now, they have their own functionality, but there is one common thing between all these three applications is that they need to have access to some most common services. So the primary requirement is these applications should remain isolated. That is, these resources should communicate only within themselves and across the internet, let's say. And they should also have connectivity to your on-prem data center using different connectivity options like VPN or ExpressRoute. Okay, this is one scenario. So I have some common services like VPN and other common services like firewall. And in another scenario, let's also consider domain controllers. So if all these three applications need communication with these services, then we have a regular approach, a standard approach where you deploy one instance of these in each VNet. If we go by this logic, it will definitely work. But the problem here is you will have to go on and deploy multiple instances of these services, and some of them are very expensive. So it will be duplication of the deployment, and it will only add more cost to your solution, which will not be accepted in a lot of scenarios, because architects have to think from various angles, correct? So that would be like from the performance point of view, from compliance point of view, from availability point of view, and of course from the cost point of view, which is also a major vertical that one needs to take care of. So how do we go ahead and ensure that I deploy these services and it will be cost effective? So in this case, what we go for is a hub and spoke topology. So we will create a hub network. So let's say I have a hub network. So this works like a common network for all the applications. So let's say we have this hub network, and we will also create some segmentations where I will deploy a pair of domain controllers. Let's say I'm going for uh, IWS approach for domain controllers, let's say. So that is, of course, we also have other pass options like Entra ID domain services. I can go for that. But in this example, I would like to go for IWS approach. So I have domain controllers, pair of domain controllers, and also I have, let's say, a firewall service. And apart from firewall, we also have a hybrid connectivity, that is a VPN connectivity requirement. So what I will do is I will host all these services in a common virtual network. So this way, I don't have to host multiple instances. And in order for these applications to utilize these services, I will go ahead and peer these virtual networks with the hub. So the application A will remain isolated from application B and application C, but still it can go ahead and access, reach out to domain controllers within one single hop, firewall within one single hop, and also with the help of virtual network gateway, which is our VPN service, we can also have connectivity to our on-prem. So same thing is applicable for application B as well as application C. Now all these are assuming that they are all deployed in one single region. So this will have reduced latency because all of them are running in one single data center, and they can reach within one hop with single digit latency. And also the deployment instances are minimized. So all the three applications, app A, B, and C, can communicate with each other. So this is a very common and most recommended topology by Azure, which we call as hub and spoke. We also have other topologies in like we have mesh topology, bus topology. So you can also build those network topologies depending on the scenario. But the most common one, what Microsoft recommends, is hub and spoke. And of course, we also have this another most common services uh, that is deployed, which is our Bastion service, which is used for connectivity between your for taking secure RDP connectivity to your resources on their private IP addresses. So this way we can have these virtual networks connected and configured, and they will be able to communicate with each other and also remain isolated and reduce cost. So what we just saw is hub and spoke topology here in one single region. So if you are planning to deploy a single application and you don't have many applications deployed in that region, you just go for one single VNet. So this is pattern one, what we call. Pattern one, we have a single virtual network, single VNet, where there is just one single virtual machine, your one single virtual network. And in that you have a segmentation where this is your, let's say, application front end. and then you have a backend. That's how you deploy. So this is your single VNet based deployment model. Pattern 2, you have hub and spoke, which we just saw. And pattern 3, it's about having multiple regions for your deployment. So you have multiple applications, or your application is spread across multiple regions for any of the scenarios like high availability or disaster recovery. In that case, you can have multiple hubs created in multiple regions. So for example, I have some workloads here. So I have some multiple VNets and I have this hub. So this is my hub network. There we go. And in region 1, this is region 1. And I will also have another hub in region 2. So this is hub region 2. And I have these multiple applications in region 2 where all they are paired in a hub and spoke mechanism. And what I will do is, instead of pairing directly between the applications, I'll have a connectivity between hub and hub. Yeah. So this is multiple virtual network in a hub and spoke model spread across multiple regions. So depending on the scenarios, you can choose any of these models, that is a single VNet, a hub and spoke in one single region, or hub and spoke in multiple regions where hubs can communicate with each other, enabling all these VNets to in turn be able to communicate only with the hubs and reach out to other regions. Now, what about the outbound connectivity? We all know that Azure by default takes care of routing the traffic to the internet, that is infrastructure provided gateway, internet gateway. But if we go and use the infrastructure provided gateway for reaching out to internet, it will be some random dynamic IP address that will be allocated. So in most of the scenarios, we don't want such IP address, dynamic IP address, where it keeps on changing. So you have a requirement, let's say you have to go ahead and whitelist a particular public IP address using which you want to make outbound connectivity. So there are two options. One, either go for a public IP address directly on resources like your Azure firewall or load balancer. But the problem with that is it is two-way traffic. So your resources will be exposed to the internet. So how do we take care of a requirement where I want a particular public IP address using which my resources within the VNet should be able to communicate with the internet, and I can use this IP address to whitelist to again other third-party services or on-prem resources. So that is where for outbound connectivity requirement, we have NAT gateway. So this is virtual network NAT, network address translation. So this service simplifies outbound only internet connectivity for virtual networks. So when we configure this NAT on a subnet level, all the outbound connectivity uses your specified static public IP addresses, and this NAT service is fully managed and resilient. So this way we can meet our outbound connectivity requirements. So how does that work? Let's go ahead and see. So I have this VNet and I have these subnets, and let's say one of the subnet requires, let's say the subnet requires an outbound internet connectivity using a specific. So what I'll do, I will go for NAT. I can go and enable NAT, which is an SNAT, and this will have either, it depends whether you want to go for a single IP address like so, or you can also go for a complete IP address prefix. So Azure offers public IP address service both in single or an entire IP address prefix, so you can take care of your outbound connectivity. So you need to configure, you can go ahead and configure the idle timeout for this, right? You need to TCP reset for unrecognized connections, or you need on-demand outbound to internet connectivity without pre-allocation. In those cases, you can go for NAT services. And of course, as I said, other options for meeting your NAT requirement is your Azure firewall, which by default, when you deploy an Azure firewall service, that comes with a public IP address, and can take care of all the inbound and outbound connection requirement. And Azure load balancer, which is specifically public load balancer, right? These are the other two options apart from NATing. Now, coming over to routing service. So as we know, all these virtual networks have built-in routing capability, and we call them as system routes. For example, if we consider a virtual network, there will be default routes available on every subnet level. That is, on the subnet, we have some default routes, the subnet and the subnet. So these default routes are called as system routes. That takes care of primarily two things. First is enable communication between resources within different subnet. So that is communication with the resources that are part of the same VNet. Second one, internet, communicating with internet, that is your internet gateway. Now these system routes are automatically taken care of by Microsoft, but in some cases you have to go ahead and change the path of the traffic. For example, let's say I have the web tier, business tier, and DB tier. Okay, so whenever my web tier communicates with my business tier, it is direct connectivity. Within one hop, my web tier can communicate with the business tier, and there is no change of path in between. It will be just straight away one single hop. And then if my business tier wants to communicate with DB tier, it will be again direct one single hop. Now, if this is okay, perfectly fine. But what if you have a scenario where you have, let's say, an appliance? Okay, so this is an appliance where uh, probably this could be a third-party firewall, or it could be anything for that matter, where you want resource 1 when it's communicating with resource 3, which is in a different subnet or in a different network. You want that traffic not to reach the destination directly. You want to change the path of this, because the system routes will ensure that these resources directly communicate with each other within one single hop. And because of this, what happens, you will miss out an opportunity of sniffing the packets, or you want to route it through an appliance for investigation purposes or logging scenarios, etc., etc. In that case, how do we take care of this? Is there any way we can go ahead and disable these system routes for certain scenarios? The answer is no, absolutely not. We cannot disable the system route, but we can go ahead and override these system routes. So when creating subnets inside the VNet, Azure, as we know, it creates the default entries, and how we bypass them is through UDR, that is your user defined route. So user defined routes are nothing but static routes that you can put. And how this works is that you use route tables. We call Azure route tables. And in this example, I would like to explain how route tables work. So let's say virtual machine 1 wants to communicate with virtual machine 3. Let's assign them IP addresses. So let's say this IP address is 10.0.0.4, and you have 10.0.2.4, and this is 10.0.1.5. Let's say this is the appliance that I want to route my traffic through before reaching the destination. So what I want is this connection, this way of traffic movement, and not the direct communication between resource 1 and 3. So that is where route tables come into picture, where route tables allow you to define the traffic that you want to route. So any traffic that is going to, let's say, 10 10.0.2.0/24, this entire subnet, such traffic should have a next hop. So you can define the next hop as a network virtual appliance, which and then you put the IP address of this appliance, which is 10.0.1.5. So you define the static route and apply it on a source of the traffic. So that goes in here. So when you apply this on the source of the traffic, automatically what happens is these user defined route will bypass the system routes for that particular traffic. So this way, whenever virtual machine 1 tries to reach out to virtual machine 3, it will not follow system route, but it would rather follow the user defined route in this case. So the traffic will be, so the traffic here is 10.0.2.0/24. So any traffic going to this subnet should go through this appliance. So that is exactly what is happening. So the traffic, if it is reaching to this destination, it will go through the appliance and then reach the destination. So this helps us understand that there are priorities also when it comes to route. So in any given scenario, if you come across a situation where any virtual network has a user defined route or a subnet has a user defined route, this has the highest priority. So any traffic going out of a subnet will first check if there is a user defined route for the given destination. If there is a user defined route, it will automatically opt for that route and reaches the destination accordingly. But if user defined route are not present, then it will check for BGP, what we call BGP, which is your BGP route, dynamic route, that is your border gateway protocol. So this is your UDR, and then comes BGP, which is your border gateway protocol. And then finally the last route, if both are not there, then obviously there will be system routes. So it will, so this is the second highest priority, and this is the third highest priority. So this is second, and this is third. So when creating a virtual network peering between two virtual network, a route is added, right? So it is not just for only within the VNet, it is also for when you enable peering, these system routes automatically get created, and it will also take care of delivering the traffic to other VNet. So anywhere where you want to bypass system route, you can either bring in UDR, which is the static route, or you can go for enabling BGP, which will automatically find the best path for reaching the destination. Now coming over to designing a solution for connectivity with on-prem using Azure Virtual Network. So let's see what we have. So first one, what we have is a VPN service. So VPN gateway is again a managed service from Microsoft, which allows you to connect to your on-premise using a public network. So how does that work? Let's go ahead and see. So let's say I have just a regular connectivity requirement. It is not business critical or enterprise level. Yeah. So I have my on-premise data center here. where I have some resources. So let's say this is my on-prem data center, and I have my Azure Virtual Network hosted in a particular region. Now I want a communication between my on-premise resource and Azure. So in this case, what we will do is preferably in a hub network. Usually, these are commonly used services. So I will go for the hub network. So in the hub network, I will create a subnet, which is a dedicated subnet for hosting the gateway devices like VPN. So let's say this is my gateway subnet, what we call. And in this, I will go ahead and host virtual network gateway service, or we call it as a VPN device. Now these VPN devices come in different models. That is, first one is your policy based, second one is route based. Policy based is a legacy technology which is not used often now. If you're dealing with old infrastructure for your on-prem, and your on-prem uses a policy based device, in that case you are allowed, you can go ahead and deploy a policy based device on Azure side. If not, if it is a fairly new infrastructure, and then in that case you will be having a route based device on your on-prem, and you can go for route based. So you can choose any of these depending on what you have. So you cannot mix and match, like, on-prem you have a policy based device, and on Azure side you have route based device. That will definitely not work. So they cannot communicate with each other. So how does this work? So basically here the requirement is less. I don't want huge bandwidth. Let's say I'm okay with let's say 1 Gbps connectivity and even lesser. And even let's make it even more complicated. Let's say I just have not just have one single on-premise infrastructure. Let's say I have multiple on-premise infrastructure in different cities, let's say. Okay, so let's say this is in Bangalore, I have in Mumbai, and there's one in Chennai. Okay, so I have this connectivity requirement. So if I go for uh, you know if I have a requirement of enabling communication between my on-prem devices, usually I'll go for an MPLS network or a service provider, and that way I can meet my requirement of connectivity between my on-prem resources. But what about Azure? So on Azure side, I will use not a dedicated network because the requirement bandwidth is less. So I will go for public network, which is nothing but internet. So we all know internet is a collection of multiple networks managed by independent organizations, and yet they are capable of communicating with each other. So this is one of the low cost network service that is available in every city, right? So what I will do is I will use VPN services which will build a private network. That is what exactly VPN stands for. It's a private network but virtual in nature. That is why it's called as VPN, that is virtual private network. So that it allows me to create a tunnel over a public network. So the underlying is the physical public network, and using which I'm creating a virtual tunnel, which I'm extending the connectivity of the private network. So using a route-based devices, I have the flexibility of creating multiple tunnels. Like I can have connectivity with my Bombay office, or and I have separate connectivity again through internet with my Chennai office and also Bangalore office. So this capability is only possible with route-based, where you have multiple site-to-site connectivity options available. But there are certain limitations when it comes to this, where your traffic, although it is communicating using private IP address ranges, it is still using the physical public network in the backend. Of course, it is safe. It is not unsafe. It uses IPsec tunnels, and you have an option of configuring encryption like IKE V1 or V2, so which is very secure. So data will be encrypted using these encryption mechanisms, and that way you can have connectivity. But the problem here is the total aggregate bandwidth what you get using these virtual network gateway is maximum 10 Gbps you can go. 10 Gbps, where each tunnel cannot exceed more than 1 Gbps speed. So if you are okay with this, then this is one of the best recommended solutions for uh, your hybrid connectivity model. And of course, you should also consider about the high availability aspect and all that. So for that, you have various SKUs available for your VPN device. So what are those SKUs? Let's go ahead and see. So there are different SKUs available based on our budget and the bandwidth requirement. We can go for any of these. So you see, you have basic, which gives you maximum 10 site-to-site connections, and point-to-site connections, that is max 128, and aggregate throughput is maximum 100 Mbps. So that means each tunnel, if I go for all the 10, if I configure all 10 site-to-site connection, each connection will be of uh, 10 Mbps max, not more than that, right? And we have other options too. So we have generation 1 and generation 2. And any SKU which says AZ in the name, that means it is zone resilient. These are non-zone resilient, wherein the others where the SKU says AZ in its name, it is zone resilient. Also, we have Gen 1 and Gen 2. The maximum you see it can go up to 10 Gbps connectivity, right? So there's also, when it says zone based and non-zone based, so there is SLA. So this SLA covers the VPN gateway and not to your network connection to the gateway or the throughput, right? So it is only about the device and not the throughput, because sometimes there will be ups and downs, because end of the day you are on a public network. So these devices not only allow you to create site-to-site connectivity, which in this case, this is a site-to-site connectivity model, site-to-site, but also these devices support point-to-site connectivity model. Now, what are point-to-site connectivity model? So let's say you have several users working from home, and these users want to be able to connect to your Azure Virtual Network, right? So yes, we can do that. So here you don't need any VPN device at user home level. So they can use just a VPN client, which is a software, and they can go ahead and connect. Here we go, over the internet. Now, what about the different authentication mechanisms we have for authorizing your single users connecting to your VPN? So we have various options, like we have a radius server, which uses your on-prem Active Directory for authentication and authorization. Or we can also use Entra ID, Azure Entra ID, Microsoft Entra ID, AAD, or it's now known as Entra ID or Azure Active Directory. Both are same. Recently, it has gone through a name change, so it is now Entra ID based authentication using Azure accounts or Entra ID accounts, and also one more authentication mechanism available, which is through certificates, right? So that is your certificate-based authentication, where you create child and root certificates the root certificate goes on this VPN device, child certificate gets installed on the devices. So these are different authentication mechanisms that we can use to meet our requirement when it comes to connecting our on-prem users. So if you see, if you go through the SKUs, you can see how many maximum P2S, that is point to site users are allowed. So you can see the highest maximum number of P2 site connections you can configure on the largest VPN gateway is maximum 10,000 you can go. Up to 10,000 users will be able to connect to your uh, VPN service, and as you go above the SKU, right, the number changes. Now, there are other limitations about this VPN based connectivity. What is that? That this VPN connectivity carries only IaaS traffic. That is traffic from your on-prem network, which is a local LAN. Let's say you have the LANs here, local LAN. So it will only carry traffic that is generated at IaaS level, that virtual machine to virtual machine, physical network and virtual network. Yeah, and nothing apart from that. But this is not the only traffic that you want to share between a Microsoft data center and Azure data center, right? There are other services that you will be using, like you have a PaaS offering. Let's say you want to use, you are using some PaaS offerings like Azure SQL. Okay. Now Azure SQL is a managed service from Microsoft, which will allow you to just take care of the database, and rest of the underlying infrastructure is managed by Microsoft. Now, problem with this service is that Azure SQL is that these are by default designed to be accessible over a public endpoint. So Azure SQL database has a public endpoint in the form of, let's say, a URL. Okay. Now, by default, URL in the sense it is over the internet. So if any of your on-prem resources want to access an Azure SQL, okay, in that case, what happens? The traffic has to go over the internet. It cannot be pushed through your VPN. Okay, so this will be always over the internet. That is a limitation. And it is not just limited to the PaaS offering, including your SaaS offerings like M365 service or Dynamics 365 service. Okay, so if you are also accessing these services for on-prem, in that case, even SaaS services, they choose internet-based connectivity. It cannot be pushed through VPN. So what if I have a business critical workload and I want a hybrid connectivity which takes care of all this traffic through a physically isolated or a completely private network, and it is not traversing over the internet. So I want it to be completely private, never go on internet. So what option do we have? So that is where ExpressRoute comes into picture. So ExpressRoute is a very powerful service offered by Microsoft. So there are different options when it comes to taking care of ExpressRoute, how it works. The first thing is, uh, let's talk about the benefits of ExpressRoute. The benefit is it can offer up to 100 Gbps. So this is the ExpressRoute service. So it offers up to 100 Gbps connectivity, right? And it supports dynamic scaling of bandwidth and direct access to national clouds, right? If in case you are using any, uh, I mean, anywhere it could be for that matter, you'll have direct access. Second, it offers you global reach. How global reach works, I'll explain in some time. And the best part is it gives also, the third point is the SLA that it gives you. So it will, it offers you 99.95% of SLA across the entire connection. So what is 99.95 SLA per month? It roughly translates to like expected downtime of 23 minutes, not more than 23 minutes per month. It will never exceed. So I have seen a lot of scenarios where ExpressRoute service has been up and running with 100% availability for several months together, right? But in some cases, of course, there will be downtime. Why? So these ExpressRoute, they give you physically isolated cable connectivity to your Azure data centers, and because of that, what happens is these network do not are not immune to physical damage, and they sometimes become very complex to set up because in most of the scenarios you will be using a service provider, and it requires extremely high bandwidth routers also on prem to take care of the connectivity. So let's see how this works. Okay, so let's consider the same scenario here what we did. So I have several data centers on-prem data centers across nation. Okay, so same concept. So let's go here. So I have data center 1. Similarly, I have multiple data centers. Let me quickly bring them up. Here you go. So let's say I have several data centers in different cities in India. Okay, so if I want to have connectivity between these data centers, of course, I will not go for VPN connectivity between these centers because it's data center to data center level, and you need more bandwidth. So what is the solution? The solution is you go for a service provider, like a telecom service provider, which offers private network service. So let's take an example of a telecom service provider like, let's say, Jio. Jio is a telecom operator, very prominent telecom operator in India, which offers physically isolated fiber optic cable service for data all over India, and it has connectivity in almost every city. So let's say this is in Bangalore, and I have one more in, let's say, Bombay or Mumbai, and one in Chennai. There we go. So I opt for a telecom operator and explain my requirement, and they will connect all my private data centers using their network, which is a service provider. Now, what Microsoft has done is Microsoft has tied up with these service providers already. So let's say there is this connectivity point, or what we call as edge location. Edge location is nothing but a connectivity point. So I have one edge location in Chennai. So even Geo has an edge location in Chennai. So let's say this is the partner's edge location. So I'll call it as a partner edge PE, which is nothing but simple connectivity point in Chennai. And what Microsoft has done is they also have a connectivity point in Chennai. So we call it as Microsoft Edge. So this Microsoft Edge is connectivity point for Azure backbone network. So Microsoft has tied up with all these service providers with the active connection there, you see, for resiliency. So this is already done. It is already connected. They are tied up. It's not like they will go ahead and configure it when you ask for it. It is already done. You just need to opt for this service, right? So all you need to do is just ask your service provider to give you connectivity to the nearest Azure data center. So, uh, you know, let's say here is your Microsoft data center where you have your workload running. So let's say you have some VNets and all that running here. So this is your Microsoft data center. And this way you can have a hybrid connectivity between your on-prem data centers and Microsoft data center using a physically isolated cable, right? And there is no way there is any internet traffic getting in between. So here it is. So this is your Microsoft data center, right? So all these data centers, Bangalore, Mumbai, Chennai, all of these can exchange traffic between your Azure workload. And the best part is that this connectivity is not limited only for AWS traffic, right? So it is, of course, carrying AWS traffic, but what it also supports is it supports PaaS traffic and also SaaS traffic. So any traffic that needs to reach Microsoft data centers and vice versa, everything will be handled through this connectivity, which offers you bandwidth up to 100 Gbps. So this is good for business critical workloads and all that, right? So especially in scenarios where you have big data analysis going on, right? And a huge amount of data that needs to be ingested to cloud for analysis purposes, backup purposes, or failover purposes. In those scenarios, VPN will not help because of the limited bandwidth and uncertainty of the connectivity, right? So it is recommended you go for ExpressRoute. Now, uh, of course, this is for business critical scenario. What about mission critical scenarios, right? I don't want to go ahead and go for service bit. So you also have ExpressRoute Direct, where if you have the budget, you can have a direct connectivity. Your own network can be extended to connect. So if you have that budget and the infrastructure ready, you can go for ExpressRoute Direct, or you can go for a service provider network. So both offer you the isolation from the network, which is very, very important for business critical or mission critical workload. Now this is about connecting to one single data center, right? So this is one single data center, which is Microsoft data center, let's say somewhere in Chennai. Okay. Now what if I have data centers in other countries also? Yeah. So can it be extended there? Of course. So let's say this is South India region, and I have one more data center somewhere in New York. Let's say I have headquarters in New York. Let's say this is my headquarters, which is an on-prem. Okay, and I want connectivity between my India data centers and my headquarters in New York. What is the solution? Very simple, right? So this express route is not limited only here in one region, because Azure backbone network is spread across entire world. So here we go. So let's say this is South India. I have one more data center here. Let's say this is East US, which is somewhere in New York. And both South India data center and East US data centers are connected using Azure backbone network, the same network which we saw in the beginning, where it uses submarine cables to connect all the Azure data centers, right? And there in East US, it is also tied up. Microsoft has also tied up with you have a service provider there. Let's say you have Comcast, which is very popular service provider. So let's say Comcast or your Verizon. Yeah. And then you have Microsoft Edge. There we go. This is Microsoft Edge, and you have this connectivity there, active connection, and that's how you have global connectivity. Yeah. So from on-prem data center in Bangalore to headquarters in New York, your entire traffic remains on physically isolated network, which is very, very important for mission critical workloads. And this will give you the global connectivity model that is that will help giving you extremely high bandwidth and security, right? And other service providers, like wherever you don't have telecom operators like Verizon, Comcast, or Geo, right? You also have satellite-based connectivity service providers through which Microsoft has already tied up, right? For example, you have Viasat as one of the service providers who will give you satellite-based connectivity. So no matter where you are, whether you are on land, right, or through water or through air, yeah, you can easily reach out. So here we go. Yeah. So this is through air, land, and water. You can have complete connectivity requirement met using ExpressRoute. Now, as I said, these ExpressRoute connections offer you extremely high bandwidth and global connectivity. As you notice, these are not immune to physical damage. So what if there is a physical damage and you lose the connectivity? So whether the physical damage is on the service provider side or it is on the Azure side, Microsoft side, because disasters can happen anytime. So you should always have a failover mechanism to handle these kind of downtimes. So what option do we have in this scenario? So of course, you will combine both the solutions, that is the VPN solution as well as the ExpressRoute. So what do you do? So you will have a VPN. So that is your side-by-side connection. So you have an ExpressRoute and also VPN-based connectivity, which goes over the internet. So let's say a VPN-based connectivity. So this acts as a failover mechanism, right? So this is a failover mechanism. So all your traffic will be primarily going through your express route, and in an event of disaster, all your VNet traffic will be pushed through VPN. So this is your VPN. So this is site to site, IKEv2. Yeah. So if the this fails somewhere, right, then you can use VPN based. So you have AWS traffic reaching your data centers through internet based connectivity, which is VPN, and your PaaS and SaaS traffic will opt a regular path of going over the internet, and it is perfectly safe. It's not like if it's going through the internet there will be a security threat. It is not like that. They have all the security features enabled, that can be safely accessed over the internet. So you have this express route with VPN failover, what we call. So this is express route with VPN failover. Yeah. Now, now look at the scenario. Okay. So as I said, the most complicated part or the challenges of express route and the VPN is its complexity involved in configuration. So what is happening here is, if I have a hub network in Azure, okay, so this is my gateway subnet, okay, and let's say I have different branch offices, headquarters, and all that needs to be connected. So I'll have to manage VPN devices, let's say in active state for failover. So couple of VPN devices, so virtual network gateway. It could be policy based, and I have some which are route based VPN devices. Okay, and what else? I have express route devices, right? That needs to be hosted. Yeah. So what happens is your gateway subnet becomes very, very complicated. Managing IP addresses, routes, and all those things, and finding a compatible device, all this becomes a challenge. Now, is there an easier solution for this? That is where WAN comes into picture. So WAN, you can consider it as a managed gateway subnet. You can compare it with that. So basically, instead of hosting a gateway subnet, what you do, you can go for WAN service. So WAN is SD-WAN service offered by Microsoft, where it is deployed at a regional level. So let's say this is one of the regions. So this is uh, deployed in one single region. And what this offers is it has got the capacity, it has got this automatic built-in ability to connect to any of these connectivity models, that is for VPN or ExpressRoute. So let's say in any of the region, you have several branch offices, let's say. So these are my branch offices using which I want to connect to my branch offices using site-to-site connectivity. So no problem. I don't have to explicitly deploy a VPN device and then connect to them. So I just, with the help of WAN service, I can have the site-to-site connection configured automatically on the Azure side. I just need to take care on the on-prem side, depending on what device I have and all that, right? So all these connections are automatic. It supports site-to-site, right? What it also supports is, let's say my individual users who are working from home, that is my point to site connectivity. Yes, even these are supported. Okay, so that is my point to site connectivity. And if I have any headquarters there, of course it also supports uh, you know ExpressRoute connectivity. So let's say there is this on-prem data center, not my branch office. Let's say there is one data center here. So let's say this is my uh, ExpressRoute connectivity. So all these connections or these devices are built in. So it is offered as a SD-WAN service where I don't have to maintain different devices and take care of the complex configuration, right? So WAN is a regional service, and this is highly available, fully managed vWAN service. It helps you save cost by using a managed service and removing the necessity of the virtual network appliances, right? It offers you improved security by introducing centrally managed secure hubs using Azure Firewall and vWAN. So this is, again, as I said, it's a regional service. So let's say this is in region 1, okay? And I can have these deployed in multiple regions, no problem at all. So let's say this is another region, and let's say I have a multi-region, like I'm a big distributor somewhere, right? And I have my authorized dealers in every corner of the world. No problem. That can be taken care of. And when I deploy these, so let's say this is in region 1, this is in region 2, this is in region 3, region 4, etc., etc. And all these are connected using Azure Backbone Network. So you have various options in there. Okay, what are those options? If you go for a basic WAN service, all the connections will be limited to one single region. Okay, and if you have going for a standard WAN service, then you can have communication across multiple regions. And it is not just that, there are other things that you can configure with the standard WAN service. What is that? First one is branch to VNet. Okay, so this connectivity, right? Branch to VNet. So let's say I have these VNet services. Okay, so WAN is connected to VNet. Let's say there is this VNet. Let me draw some VNets here. This is on the Azure side. Yeah. So what kind of connectivity models I can have? So branch to VNet. Yes, it is taken care of from here to here. So it will go through WAN service. So this is branch to VNet. What else? Branch to branch. Yeah. So that is one branch communicating with other branch, right? So this is branch to branch connection. Then ExpressRoute global reach, right? Of course, you know, you have this remote user to branch, right? So a remote user to branch, let's say any of these branches, right? It could be here or here. Yeah. VNet to VNet, of course, you don't have to go for peering again, so that will be again taken care of. So let's say I have multiple VNets. So VNet to VNet communication, that will happen through again VWAN, like say. So this is your VNet to VNet, right? And this is your remote user to VNet. Okay. And then basically, you know, let's put it across in any to any. For example, okay. So if I have any user here, right? Any resource here that needs to communicate with any of the resource here, no problem. It can be achieved through this SD-WAN service. So that is what we call as any to any, right? So this way you can have a globally spread across WAN service that will help you communicate to any endpoints in your infrastructure, right? So this is what we call as a global transit network with virtual WAN. So next what we have is design for application delivery services. So in this, we are talking about load balancing solutions. So different types of load balancers what we have. Let's see where to use in what scenario. Okay, here we go. So we have load balancers working on different network layers. So the first one is ALB, what we call as Azure Load Balancer. Now this Azure Load Balancer is a layer 4 load balancing mechanism, and this takes care of distributing workloads to multiple resources in the backend within one single VNet. So this is layer 4. And then you have both, under this you have both public load balancer and also internal. So you have both the options to choose from. That is layer 4, Azure layer 4 load balancer, public and internal. So here it uses IP, port and protocol to route the traffic to the backend resources. Then we have application gateway. Now application gateway is layer 7 load balancer, which do not use IP address port and protocol, but rather uses URLs. That is, it has the ability to differentiate between an HTTP, HTTPS traffic. It can go ahead and analyze the URL and read it, right? So these it uses URLs to load balance, right? And other benefits of application gateway we will see in some time. Like it is it comes with built-in WAF if you want. That is your web application firewall to protect your application resources, right? And since it is a layer 7, it also helps you with configuring SSL termination, SSL or TLS termination on load balancer level. You don't have to do it on a server level. And it supports both PaaS and other IPs also in the backend. And of course, it's a regional service. So what is the difference between Azure Load Balancer and Application Gateway is that this is uh, mainly used for at one single network level. For example, So I have a bunch of virtual machines, let's say my front tier, right? Well, that is the front end of the application where I have several web servers and they need to load balance the traffic to the backend servers like my business servers, right? Internally using a port rather than a URL. In that case, I'll go for L4, layer 4 load balancer, right? So all these resources are communicating here. So let me just a nice image. So you see, that's the scenario where I'll be using a layer 4 load balancer where I have the public load balancer in the front end, which is load balancing the traffic using port 80. Now notice it is using port for load balancing, port and IP address in the backend, right? And all these resources in the backend are part of one single subnet, or it's in one VNet, one single VNet. That is the limitation. It cannot load balance to multiple VNets. It will be always within one VNet. And you have to use IP address port and protocol to load balance. Now, there are also other limitations like it follows hash algorithm where it will randomly route the traffic to these resources, and you should be okay with it because all these resources are doing the same job. They are replica of each other. It doesn't matter where the request reaches unless it is a stateful requirement. So if it is a stateful application, in that case, you have to enable what we call as session persistence. It supports, or we also call as a sticky session, which you can enable. Otherwise, it can randomly load balance. So you should be okay with that, where the traffic is distributed randomly to the backend web servers. And when web servers needs to communicate with the business tier, then you use internal load balancer, where traffic is received at a private IP address. Here, traffic is received at a public IP address. So it will load balance to the business tier, right? So layer 4 load balancing, for it supports both UDP and TCP, right? It manages both inbound and outbound connections, and it has both public and private uh, connectivity model, and it uses simple IP port and protocol based rules. And another most important feature of this is it has got built-in health probes to determine what is the status of the backend resources. If any of the virtual machine fails, the health probes will detect it and it will stop the traffic to that particular resource till it is up and running again, right? So this is where you will be using layer 4 load balancer. On the other hand, application gateway is a little more advanced. So this is specially designed for application load balancing, where you see it can load balance using the URLs. It can go ahead and see. So let's say there is this end user who wants to connect to your application. So this load balancer has ability to host a web application firewall, which is built in. So WAF, and it's an optional service. You can opt for it, or you can bring in your own web application firewall in the form of a virtual machine and use user-defined route to route the traffic to it before it hits the load balancer. Anything is okay, but this does not route the traffic based on IP address, port, and protocol. Mainly, it is designed for URL based. So it can sense the incoming URL and it will help you route the traffic accordingly. For example, I have requests coming in from end users, right? So there is this user who is trying to access some URL. Let's say this is www.cloudthat.com /image /abc.jpg. And there's another user, here we go, www.cloudthat.com /video /abc.mp4. Now, these URLs, these requests should reach a particular resource in the backend. So in this case, you cannot go and use a regular layer 4 load balancer, right? So you need to route based on these requests to the appropriate resource in the backend. So that is where this application gateway comes into picture. So it has got this HTTP, HTTPS listener in the backend. So you can go ahead and highlight the keyword, like if the incoming URL has a keyword like image, such request should always be routed to the resources that are sharing images in the backend, right? So any request which has image in that, and requests that have video inside of them, right? So such requests should always go to another set of resources in the backend, right? So here we go. So basically it is application level load balancing using URLs. So this is where you use application gateway, and this does not have limitations like all these resources should be present on in one single VNet, unlike your layer 4 load balancer. These resources could be in multiple VNets, and of course they can also be running on your on-prem. So it can help you load balance to your on-prem resources using a hybrid infrastructure, right? Whether it is a ExpressRoute or VPN, right? So it can go ahead and load balance to your hybrid. It supports uh, public and private communications both. So this will take care of your application level load balancing. Now these both of them are regional services. Okay. Now what if I want to have global load balancing requirement? So there are two services available for that. One is Azure Traffic Manager, and then we have Azure Front Door. Okay. So how does this work? Let's go and see. So when we say Azure Traffic Manager, this is again a very popular service from Microsoft when it comes to uh, routing global traffic. So this is a DNS based load balancer. It uses DNS mechanism to load balance the traffic. It's always public to public, so it uses DNS. Yeah. And when it comes to your front door service, this is you say you can it uses on any cast, right? So you have Azure Front Door. It doesn't use DNS, but rather uses any cast capability of your Azure backbone network, which will always help you connect to the nearest endpoint that reduces distance latency, and it will help you get to Azure backbone network as quickly as possible. Yeah. So let's understand how Azure Traffic Manager works. So there we go. Azure Traffic Manager, it is helpful when it comes to distribute traffic optimally to services across global Azure regions, right? So it provides a range of traffic routing methods to distribute traffic such as priority, weighted, performance, geography, multi-value, or subnet. So let's see how this works. So let's say I have this requirement. So let's quickly understand how Traffic Manager works. So in this case, I'm taking care, I'm using priority-based load balancing. So let's say I have multiple region deployments. So this is primary region, and these are failover sites. Okay. And what happens here is I have deployed Traffic Manager for what we call as a priority based, that is for failover and all that. So how does that work? I will flag one of the site as primary and then other two sites as failover. So my Traffic Manager profile will maintain this priority table. So the first is always primary is the first site, and failover site A and site B are failover site, and this will maintain this table, and it has got a recursive DNS service built in. So whenever you have your end users connecting, what happens? So when your end users reaches your application, the request reaches the recursive DNS server, and it will ask for a page. So the recursive DNS server will reach out to your traffic manager profile and request for the best site for this user. So since my traffic manager is configured for priority, it will always return with this URL for site A. So it will always return with site A URL. So when this URL is shared to the end user, so that person will always get connected to this site every time. Yeah, all the user, not just one user, all the users will keep on connecting to primary site. And if in a scenario where the primary site fails, it is degraded, it is not responding, that will be sent through help probe. And what traffic manager does for the other users when the primary fails, so traffic manager will immediately start giving second URL. So when second user, like after failure, when user comes in, the recursive service will reach out to the traffic manager, and it will ask which is the best site. It will say site A is degraded, it is down. So it will respond with second URL, and that way this user will reach out to second. So this will happen. It will give you the feeling of automatic failover, and that way you can go ahead for uh, you know, uh, all your users will be connecting to site 2. So this is priority based. You can also go for weighted. Weighted in the sense you can choose like I want 50% of the traffic to go to primary, then I want 30% of the traffic to go to secondary, and let's say 20% to come to tertiary. So you can configure it that way. So accordingly, the traffic manager profile will respond to the recursive queries. When it comes to performance based, it will maintain a latency table of multiple sites, right? And always return the URL for the best performing site for the user. So basically it will look at the location of the user. So let's say this user is in India, right? And I have one site in India, hosted in India data centers, and this is in UK, and this is in US. So it will maintain a latency table. So when somebody is requesting page from India, of course, for this site will be having the least latency, so it will always respond with the URL for India location. So that way, the user will have very least latency. People coming from US, it will look at their IP address, it will check the source, and based on that, it will respond. So that is your performance based. You can also configure it for geography, right? So all the users coming from India should always go to one particular site. People coming from US should go to always one particular site, right? So like that, you can have this traffic manager route the global traffic using DNS service. Now, if you don't want to use traffic manager, you also want, let's say, uh, primary, or let's say for example you want to have Anycast technology based connectivity. In that case, you can go for front door. How does that work? Let's go and see. Here we go. So that's our front door service. So Azure front door service enables you to define, manage, and monitor the global routing for your web traffic by optimizing for the best performance and instant global failover for high availability. Of course, both are doing the same job, but this is more advanced, right? So you choose the front door service when you need to ensure that the requests are sent to lowest latency backends every time, right? So this is region 1, region 2, region 3. No matter from where the users are coming, you want them to hop onto Azure backbone network as quickly as possible, and from there it should redirect you to the lowest latency region as quickly as possible, right? Or when you have primary and secondary backends using priority, you can do that. Or if you want to distribute traffic using weighted coefficient, so basically it is doing the same thing as Azure Traffic Manager, but this uses Anycast and this uses DNS. So it is highly recommended that you opt for front door service, because this can also double up for CDN, that is content delivery. It can be done through the same front door service, right? It can be easily integrated for your CDN services. So what is CDN? CDN, it's it offers developers a global solution for rapidly delivering high bandwidth content to the users by caching their content at strategically placed physical nodes across the world. That is, let's say you want to go ahead and build a service like Netflix. Okay. So if you have a service like Netflix where you want to stream audio, video, where you will go ahead and store all those data in one particular location, right? That is your storage account somewhere, right? So you have all these videos. Yeah. Now let's say this is in one particular region. For example, this is in East US. So if you store all your movies, videos, etc. in East US data center, and you are expecting global audience to opt for your service, and let's say here this user is in US, the guy is in UK, is in India, yeah. So people in US, when they are accessing the videos, for them it will be flawless because the distance is very, very less. But for people in UK and India, there will be latency issues. So how do we solve this problem, right? So that is where Azure Microsoft CDN network comes into picture. So how does that work is, we have already seen that. So what we saw here in global infrastructure, okay, we noticed how these data centers are spread across and how network is also spread across. But what we did not notice is these edge locations, which are POP locations. So all these you see, these are all POP locations. So these are connectivity points and also caching zones. That is, the data need not necessarily be sitting in the data centers. You can cache them to the nearest location as possible. For example, you see, if you have to, you're somewhere here in Africa and you want to reach out to backbone network as quickly as possible, you don't have to reach out to all the way to the data center. You can reach out to the nearest POP. And especially when there is a movie and all that, you can choose that such data gets cached here to the nearest place possible to your end user, so that you have very least latency, and it doesn't require any buffering and all that, right? So this is how CDN service works. Here we go, right? So let's say you have a client somewhere in US. Yeah. So let's say this client is in India, and uh, the data or video is stored in US. So initially, when you directly access, a client access the source of the data using your storage account endpoint, uh, the request has to cross all the 7 seas and reach the US from India, right? So that is a huge distance, and let's say it is taking around 120 milliseconds, blah blah blah, which is too much. Yeah. And you don't want this to happen, because if your videos or movies keep buffering, you will lose out on most of your subscribers, and they will flag your service as not good, right? And in turn it will hit your business. So how do you go ahead and make sure that all these files are present close to your end users all over the world? if you go ahead and create, let's say, storage account everywhere in every data center, that will be a huge expense, right? So what is the solution? That is where CDN. So you configure, you connect CDN service to the origin of your data, with the source of your data, and you have these edge locations, thousands of POP. So this is the POP all over the world. So whenever from any particular region, when the first client makes any request, right? Why I'm talking about this part is that this CDN service is a pull type, not push type. So that way it is very, very cost effective. So what happens when the client requests, okay, for the first time, what happens? He will experience latency, right? But what happens is the Microsoft or CDN network will pull this data and stores it to the nearest cache location for the end user. So let's say the entire video using Azure Backbone Network will rapidly get dumped in the nearest location in India. So where is that nearest location? You have somewhere in Mumbai. Here we go. So you see, I have several locations, BOM 30, right? PNQ 30. So this is in Mumbai, this is in Pune, right? And you have in Nagpur. I'm not sure whether it is Nagpur or not, but anyway. So these are all, POP locations. So the data gets transferred through this Azure Backbone Network in a much more fast way and get cached here. So the first user will experience some latency from that region, right? But the consecutive users from that location, consecutive users, right, will not experience this huge amount of latency. Why? Because the data is now sitting close to them. So it will be much, much faster for them. So that is how CDN works. So this is mainly for your static data, right? Like images that go in your website, audio video services, right? And also it helps you with compression of the data. It will help you compress the data to deliver it in a much more faster way. The scripts that is there in your website. So all that can be pushed through CDN services. So that's it for today in this video. And in the next video, we will talk about application protection services, like what is service endpoint and when to use them, how they function. And we will also talk about private link, Azure private link service, and then NSG, and Azure firewall service, DDoS protection. All these we will look into our next video. So thank you so much, and stay tuned.